Hello everyone, my name is Sam, and today I'm going to talk about the effect of glucose on helping regeneration in Gambusia affinis. And the Gambusia affinis is the fish like this picture, and it's commonly known as mosquito fish, and it was mostly found in standing or slow-flowing fresh water. It has string-like body that reach maximum 6 to 7 cm in female, while the male reach 4 cm. And why did we choose the Gambusia affinis as our models? That's because it's great regeneration ability. First, let me introduce what is regeneration. Regeneration is a process of renewal, restoration, and growth of damaged part of any living organism. For example, in this picture, there is a fin-lobe fish, and when it undergoes the regeneration process, you can see the new fin grow in the right fish. And what is glucose? Glucose is a single sugar that has 6 carbon atoms, and it is also a major source of energy. And why did we choose the glucose to test? That's because the different glucose lead to various physiological complications in animals, like hyperglycemia or hypoglycemia. The hyperglycemia is like in this picture. The situation that we have high blood glucose, and hypoglycemia is in contrast. Glucose is thought to hamper the regeneration process as well, and the word hamper means to restrict the movement. So the study aimed at explanation of effect of auto level of glucose on regeneration process. And next is our material and method. We collect the same size and color fish for experiment, and rest will release back in the pond. We cut the tail fin of the cracked fish in the pond and leave only 2 mm tail fin. The fish with amputated will randomly distribute into control group and treat group, and there will 5 fish per bowl. The control animal will keep in filled pond water, while the treat group receive 10 mmol glucose, 20 mmol glucose, and 50 mmol glucose, or 100 mmol glucose. And we have 2 sets of experiments. Both are for 8 days. One is chronic treatment. The glucose treatment was given to fish only on the first day of the regeneration. And the other is acute treatment. Solution of the same glucose concentration was replaced daily. And next, I will show you the result of chronic treatment and acute treatment. First, this is the table of chronic treatment. As you can see, this table didn't mention the data of day 1 to day 3. That's because the regeneration began from the 4th day. And throughout the observation period, 10 mmol glucose solution accelerates regeneration process in tail fin as compared to control and other glucose treat fish as seen in table. And 10 mmol glucose solution had higher length of regeneration tail. At 20 mmol, 50 mmol, and 100 mmol glucose solution, glucose accelerates regeneration as compared to control. However, the acceleration was not statistically significant. And the figure is the effect of glucose on tail fin regeneration of chronic treatment. In this figure, the axis is number of days after amputation, and the word amputation means to cut off something. The y-axis is the length of regenerated tail, and the unit is millimeter. And you can see the front line is 10 millimole glucose, and we can see clearly in the figure that the acceleration of 10 millimole was significant. And this is a table of acute treatment. In treatment groups, initially there was no significant difference in regeneration rate as compared to control. However, by accident, there was significant reduction in fish treated with 10 millimole, 50 millimole, and 100 millimole glucose dosage. And next, let's talk about this discussion. The first discussion is why the 10 millimole glucose solution accelerates the regeneration process as compared to other doses in chronic treatment. We think that regeneration accelerating effect of glucose at lower doses is significant as compared to higher doses, and this result is agreement with other paper. And the second discussion is why the 20 millimole glucose solution delayed the regeneration of tail fin in Gambusia affini in acute treatment. You can see the right table that 20 mg glucose solution actually delayed the regeneration of tail fin, and we think it was influenced by insulin. So, what is insulin? Insulin is a hormone which controls blood glucose level. And for example, in our body, the insulin is produced by the organ like this part. And when the dose of insulin was increased, it will cause the retard regeneration. The mechanism of the insulin is when we have higher blood glucose level, the insulin will be stimulated and act. It will increase the concentration of insulin, and the high concentration of insulin will cause the blood glucose level reduce and retard regeneration speed. So our conclusion is the study demonstrates a crucial role of glucose at its best level in the regeneration process. And in this paper, we think the best level is 10 millimole glucose. And the same conclusion is proved at the Libra fish regeneration tail fin. So next, my presentation to this paper. In our material and method, we control the same color, size, and numbers of fish, but we didn't control the gene. So was the regeneration of tail fin affected by gene or insulin? We can definitely know. And the second criticism is our conclusion is glucose plays a crucial role at the regeneration of tail fin in Gambusia affini and the Libra fish, but both of them are freshwater fish. So if the salinity change, how about marine animal? Marine animal like sponge, starfish, sea anemones, and coral have great regeneration ability. We can test them in the future to prove the marine animal may influenced by the glucose. this is my presentation. Thanks for your listening.